Hi, welcome to Mathy Python. Here I talk about the solutions to the problems for episode 6, which was on lists and tuples. Hopefully you have attempted those. For the first problem, we create a list of the first 10 perfect squares, starting with 1, access the first, last, and middle elements. So this is a common pattern where you want to create a list. So you start with an empty list, and then you build up the things you want to put in the list, and then you append them to the list. So the real point of this problem is not really perfect squares. It's how do you build up a list. So again, squares is empty for I in range 1 to 11. Stops at 11, doesn't include it. So this will be the integers 1 through 10. Then I append whatever that square is, print it out. 1 squared is 1, 2 squared is 4, 3 squared is 9, up through 10 squared is 100. To access the first, last, and middle elements, the first element, it's 0 based. Python is 0 based, so you say square sub 0. The last element, that means the last element. And then the middle element, I'll look at the length of the list divided by 2. That's odd. That's going to be a float, so I will take the integer of that. And we get 1, 100, and for the middle element, it's 36. We'll cover this more in the intermediate class, but you may see this. It's something called a list comprehension, where you can do this building up of a list in one line. Just such a common pattern that it makes sense to have a one-liner. So here we say squares equals, then we put brackets to, square brackets to indicate a list, the for loop for I in range 111, and then what are we putting in it? I squared. So squares equals I squared for I in range 1 to 11. Problem 2, we have a list of temperatures, and we want to find the highest, lowest, and average temperature using built-in functions. So I copy-pasted the temps here. The highest is just the maximum of the temps. The lowest is the minimum of the temps. For the average, I sum up all of the temperatures and then I divide it by its length. And then I rounded that to 1 decimal place. Number 3, without running it, predict what each line prints, then check it by actually running it. So we have a list, 1, 2, 3, 4, 5. Print A, 1 through 4. So again, starts at 0, index 1, 2, 3, 4 does not include the 4, so that's going to print 2, 3, 4. A of start to finish, -1 step size means you reverse it. So instead of 1, 2, 3, 4, 5, it's 5, 4, 3, 2, 1. Print A, the step is 2, that means every other 1. I didn't specify the start, so it'll be 0 by default. So it starts at index 0, which is the value 1, skips 2, then 3, skips 4, then 5. Let's see if that's right. And it is. Number 4, given a list of 5 numbers sorted in descending order using both sorted, the function, and sort, the method. So with sorted, a function, you put your list as an argument. With sort, you write out the list and then the list variable name and then put dot sort. So that is an internal, it's a function, but it's an internal function to lists. So that's the difference between the two. Now the mechanics of how to do it. I start numbers 1, 2, 3, 4, 5. Another difference, sorted returns a sorted list, but it doesn't sort the list itself. And the numbers dot sort is going to actually change the contents of the variable numbers. So it doesn't just return something, it changes the list itself. Either way, we get 5, 4, 3, 2, 1. Number 5, create a tuple of the RGB values for your favorite color. Unpack it into 3 variables and print each one. I chose purple. Look up the values. It's 128.0, 128. RGB, if you're not familiar with it, it's red, green, blue. Any color can be made out of red, green, and blue. So you give it a value from 0 to 128 for red, for green, and then blue. So if you crank red and blue all the way up and no green, you get purple. And then I extract the red, green, and blue from that. The red is at index 0. The purple is index 1, which is 0. Blue is at index 2. Problem 6. Predict the output before running it. Then fix the code so that A remains 1, 2, 3 after appending to B. That'll make sense after we run it. So I assign the list 1, 2, 3 to the variable A. Then I say B equals A. So what does that actually do? It looks at the memory address associated with A, and B will point to that same memory address. So B append 4, that will change whatever is at that memory address, which is 1, 2, 3, now with a 4 on the end. A points to the same place in memory. So it's going to give me 1, 2, 3, 4, and then B will give me the same thing. I never explicitly change A, but its value does change by changing B. So again, line 1, A is 1, 2, 3, B is A. So it's not a copy of 1, 2, 3, it's pointing to that memory address. Then I append something to B at that memory address, and then that also changes A. The fix to this is to explicitly make a copy. So instead of saying B equals A, you say A.copy. And now they will stay independent. Number 7, given these scores without using a loop, remove all duplicate scores and return them in the ascending order. So the scores is the list. We can change it to a set that dedupes it, cast it back to a list, and then sort that. Then when I print it, let's see, what were the duplicates? 92 is no longer in there twice. 88 is only in there once, not twice, and it is ascending. Number 8, given a list of named score tuples as follows: unpack each tuple and print a formatted line for each student. So I copy pasted the line up here, results. So result will go through these tuples, and then I pill out the name, and then I pill out the score, and then I print those out. Number 9, given a matrix, when we get into NumPy, you'll see that there's an efficient numerical library to deal with matrices. So if you do any really heavy lifting with matrices, you won't use straight up Python. They're better libraries. But for the purposes of illustrating how row and column access would work, we will create this two-dimensional list. So it's a list of lists. So inside we have a list that's 1, 2, 3, another list that's 4, 5, 6, another list that is 7, 8, 9, and those 3 lists are embedded in a larger list. Access to value 5 is extract the entire middle row and entire middle column. So value 5, it's in 0, 1. So the row indexed by 1. And then within that list of 4, 5, 6, 5 is at the 0, 1 index. So it's 1, 1. Print out 5. The middle row is, again, the row is 0, 1, 2. So the middle row is 4, 5, 6. So that's how you get the middle row. For the middle column, you need to pull out these integers separately. So matrix 0th row, the entry at index 1. Then the next one is in the row indexed 1, and then 0, 1. That gives me the 5. And then for the last value, I have the row 0, 1, 2, and then the middle entry is 0, 1. Given two lists, names and scores produce a single sorted list of score named tuples sorted by score from highest to lowest. So if you zip names and scores and then turn it into a list and then sort that will give you the answer. So what zip does is that it returns a tuple of Alice 88, then Bob 92, then Carol 75, then Dave 100, Eve 84. So it's zipping these two lists together. So that's how you can traverse to two lists item by item without having to get into tricky loops to make that happen. Problem 11, given a list of daily expenses, here they are. Build a new list where each element is the running total up to that day. That last element should be the same as the sum of expenses. So the expenses, just copy paste that in. Again, I'm building up a list. I start with an empty list. I do the thing. I append it to the list, and then I print it out. So in this case, for I need the index. So I'm going to say for I in the range from 1 to the length of the expenses plus 1 to plus 1, because Python goes 1 beyond 1 less than whatever number you have here. So the running total, I'll then append. I'll sum the expenses from the beginning of the list up to whatever the current one is, round that to 2 decimal places, and then append that to the running total. Start at 1 because the first element is just going to remain the same. There's nothing to add to it. So I get 32.5, and then 18.75 plus 32.5 is 51.25, so forth. Let's look at number 12, which is list rotation. This one I thought was a little tricky. Write code that rotates a list by n positions to the right. For example, rotating 1, 2, 3, 4, 5 by 2 gives 4, 5, 1, 2, 3. Use only slicing, no loops. So let's look through an example to figure out what's going on here. So let's say we start with 1, 2, 3, 4, 5, and then we rotate by 1. So that means take the 1, 2, 3, 4. Those get scooted to the right by 1. The 5 falls off the end of our conveyor belt and pops back at the beginning here. If we do that again, then now the 5, 1, 2, 3 gets scooted over to the right by 1. The 4 falls off and it becomes the beginning. We could also just say that's rotating by 1 twice is the same as rotating by 2. Okay, so how do we do this? So I defined a function here with a list and however many places I want to rotate by. N is n mod the length of the list. So if you give a number that's greater than the length of the list, then it'll mod that. And then we return negative n to the end and join that list with a list from the beginning to negative n. Why would that work? Let's look at an example here. So we rotate this by 2. Here's our original. Here's what we end up with, like we saw. So the 4, 5 is the last two elements. Those get scooted to the front. So what was the tail is now the head. So that's how we got minus n to the end. So that'll be the beginning of our new list. And then the list from the beginning up to 2 from the end is 1, 2, 3. And then we put that at the back. So it's the list negative n. That's this one, which now gets put at the head. And then that gets joined with the list up through -2, which is the beginning of this original, which is now the end of the rotated. Try it on a bunch of test cases. 1, 2, 3, 4, 5 rotated 2 gives us 4, 5, 1, 2, 3. Rotated by 1, we get what we expect. 0 doesn't rotate it at all, so that works. Rotated by 5, that's bringing it back to its original state. Rotated by 7, that brings it back to its original state, and then 2 more. That's why we have this line 2 here. Produce a single flat list using a loop and extend. This will flatten a list of lists. If you had a list of lists, this wouldn't work anymore. You really kind of need recursion for that, and we haven't talked about that. So yeah, let's just do it for this example. So to flatten it, again, I start with the result, which is empty, and then I do the thing to build up that list, and then I return it. So for item in the nested, so when it loops through this nested, the first item is going to be this whole list, the sub list, not the individual items within it. So that gives me a list 1, 2, 3. So result extend takes everything. If you extend the list by another list, then it will take all of the items within that list and append those to, in this case, result. So this gives 1, 2, 3, and then it goes to the next one. 4, 5, 6 is a list that gets extended. Result gets extended by that. So that adds 4, 5, 6 as individual numbers. And then 7, 8, 9, same thing, and it will flatten it out. There is an issue in this that if you had nested 1, 2, 3, 4, 5, 6, 7, 8, 9, those as lists, but then you had singleton items, these singleton items are not lists. So now the extend will get confused because that's expecting a list. So I go through here, I ask in the loop if it is a list, if it is instance item list. That means if item is of type list, then I will extend it, which grabs the numbers within that list and puts them in the result. If it's not, then I assume it's a singleton, and it will append that single number to the list. So that works for lists like this. Given a list of numbers of possible duplicates, find the second largest unique value without using sorted. So I looked at dupes. There's some duplicates in here. To dedupe it, I looked at the set, so that takes out all the duplicates. Find the max of the duplicates also as a set. Use set subtraction on here, so that takes the set of dupes. It subtracts out whatever that maximum is. That leaves you with a set that does not have the maximum in it, and then you can pull the maximum out of that. A dot product given two vectors as lists, compute their dot product. So the dot product means that you multiply the elements in the same indices and then you add them up. So 1 times 4 plus 2 times 5 plus 3 times 6. So I have these two lists. I just copied it, copy pasted it into the code. The dot product initially is 0. And then for I in the range of length of u, it's a length of either one, I'm assuming they're the same length. Then I peel out u sub I, initially 0, times u sub times v sub I, and add that to the dot product. So initially I get 1 times 4 is 4. Then I add to that 5 times 2, which is 10, and then I add to that the 3 times 6. So that comes out to 32. A cute little one-liner for this. So I could use a tuple comprehension. We talked about list comprehensions earlier, but you can also use it for tuples or dictionaries or whatever, and use this one-liner. So for A, B, N, if I zip UV, then that's going to be the tuple 1, 4, then 2, 5, then 3, 6. So for A, B, and that tuple, A is whatever the first element is, B is the second. I multiply them, and that creates a tuple, and then I sum all of that, and then take the dot product. I hope you enjoyed these. If you have any further questions, please leave them in the comments. Thank you.